Hey everybody, welcome to Mastering VMware 6.7 training session. This is your trainer, Pankaj Verma. Here's a brief introduction about me. So I have around 12 years of experience in VMware space, and I have worked on majority of VMware Vsphere products starting from Vsphere 4.0, and these are my certifications which I've done over the year. So I'm certified professional VMware Vsphere 5.5, 5.0, 4.0, and I have various sales and technical sales professional certification. I've also done VCV Block Foundation certification, and I've also done various certification on Microsoft products. So my experience is not just limited to virtualization space. I have also good hands-on experience on Citrix desktop and application virtualization solutions. And besides that, I have good hands-on experience on managing various hardwares like Cisco UCS, HPC 7000, HPC 3000, and other Cisco, HP, and Dell rack servers. So without further ado, let's get started. So today we are going to discuss following topics. So we'll begin with discussing about history of VMware, the VMware timeline, how it actually evolved, and then we'll talk about virtualization in general and what are its benefits, and then we'll begin with installing ESXi. That's the first piece of our lab, and this training would be majorly focused on doing hands-on on everything, and also discussing theoretical part. Like while doing the lab, we'll discuss each and every option of how to install and what sort of prerequisites are required to deploy a vSphere 6 or 7 environment. And then we'll discuss the core components of VMware vSphere, what are the various layers involved, and what is the right order to deploy all those VMware vSphere, and how to set up all its advanced features like HA, DRS, vMotion, and we'll discuss the rest once we have the lab setup done, and then how to set up shared storage in ESXi, and how to set up how to install vCenters and set up virtual clusters, and take the advantage of features like HA, DRS, vMotion, storage vMotion. All right, so let's begin with history of VMware. So when we talk about virtualization in general, it's not a new product. So it was also achieved by IBM in the mainframe architecture. They have developed a technique to run various workloads in a time sharing fashion. So VMware mainframe architecture was a bit different. So VMware has done the same on x86 architecture. So the first product that VMware has launched was VMware Workstation. It was the first commercial product. So it was more like how to run virtual machines on a single piece of hardware. So let's say if you have your simple desktop or a laptop machine, so and you want to try your multiple let's say operating systems. So for example, on a Windows XP machine, I can install a Windows 2000 virtual machine, and I can also install a Linux virtual machine. So yeah, but yeah, those machines were like locally accessible. So from my desktop itself, I can run all those virtual machines and access them, and I can learn those specific operating systems. And so now the second product which was launched was GSX Server, and it was an improvisation for VMware to VMware Workstation. So VMware Workstation used to support like up to 1 CPU and 1 GB of RAM. So GSX supported up to 2 CPUs and 2 GB of RAM, and it also provided an option to access your virtual machines remotely. So you're not just limited to access those VMs locally from your workstation, so you can access those virtual machines over the network. All right. So these products were like basically dedicated to create virtual machines, and they were not an enterprise class solution, and they were actually called as type 2 hypervisors. So what a type 2 hypervisor is, like you require a guest operating system, and over that you install some like hypervisor, and then you start building a virtual machines. So on the contrary, we have ESXi, ESX and ESXi server, which is a type 1 hypervisor which you install directly over your hardware. So which is again a very, it has a very small footprint as compared to Windows operating system. So when it comes to ESXi, it's an enterprise class server virtualization product, and it is highly scalable, and you can deploy a very high number of virtual machines with very high specs, and we can achieve a very high consolidation ratio. So besides hosting virtual machines, it provides you a lot of unique features like high availability, DRS, vMotion, storage vMotion. So we'll discuss these features once we have the lab setup done, because these features require a vCenter to be deployed. So it's good to have a hands-on to gain more understanding into these features. So once we perform the labs, we'll talk about these features. All right, so let's move on to the next slide. So here we talk about virtualization. So what virtualization does and what benefits it brings to the table. So it's good to have a comparison to the physical silos and how exactly it differs, and what sort of features and what sort of improvisation it brings to your physical silos. So let's talk about a traditional x86 architecture where we have one-to-one mapping per physical server. So let's say in my typical data center environments, I have servers like my web servers, my database servers, my application servers. So they were generally being deployed on one-to-one fashion. So on like one physical server, I'll be running my web server, and on one physical server, I'll be running my SQL, my Active Directory, my DNS servers, and my database servers. So typically in x86 architecture, in the physical world, the server utilization on majority of the server was somewhere between 5 to 15%. So it was not very optimized scenario. You were not getting the higher utilization for your hardware. Like you've been spending a lot in your hardware, but still you're not getting that return of investment on that physical hardware that you have deployed. So it requires electricity to run those hardware, and the cooling, and the maintenance of the hardware. So there's a huge cost which was involved in maintaining those physical servers, and again you are not getting the maximum out of your investment. So what x86 virtualization did was, it actually let you abstract the hardware. So what I mean by that is, you can create multiple virtual containers, and they would be having same set of hardware like you have in your physical counterpart. So you would be having a CPU, virtual CPU, memory, a virtual NIC, and a virtual disk. So on a set of physical hardware, I can create these multiple virtual containers, and I can run different operating system on those containers. So the underlying hardware would be like for example, I have a single server, and I can run 10 virtual machines. So let's say on 2 virtual machines I'm running, if we talk about this, let's say these are 2 virtual machines. So in this virtual machine, I can simply run Windows operating system. In this, I can run Ubuntu or Linux or any other operating system. So and this was highly scalable. The number of virtual machines supported is quite higher, and so by adopting virtualization, the very first inherent benefit that you get is high utilization of your hardware, and this way you can bring down the number of physical servers, and you can achieve maximize use of your hardware. Okay, so before adopting virtualization, the typical hardware utilization was like 8%, but after deploying virtualization and then hosting virtual machines, you can get somewhere around 80% utilization. Okay, so again, this is just a contrast. So we have, everything is pretty much same. When we talk about physical infra, we have like the underlying supporting hardware is the same, So you have an Ethernet, you have your network through which these physical servers are connected. You have your fiber channel storage. So some of the servers might be consuming SAN storage from this, and you have this iSCSI storage and NFS storage, which is being accessible through Ethernet. So fiber channel is a storage which requires a dedicated network. Okay. So now let's see in the here in this physical infra you have one-to-one mapping. So if you see on every physical server you have a single OS and that single application running. So now let's see on the virtual counterpart. If you see the underlying hardware or underlying supporting network and storage infra is the same, but now on the physical host itself, now you have your hypervisor layer, which is your ESXi, and then on that you are hosting multiple virtual machines which are running their respective applications. So if you see, like, you have achieved a higher consolidation ratio, and as a result you have achieved, you know, optimized user hardware. So the thing, for example, if you see in the previous picture, like just I'm putting an example. Let's say, like, I have 1 2 3 4 5 6 7 8 apps running. So if you go on the virtual counterpart, so instead of 8 servers here, I have just bring it down to, like, you know, 2 servers. So that's the higher consolidation ratio. So you are actually investing less in buying the hardware, and then you are utilizing your hardware to the max. Okay. So what are the other benefits of using virtual machines? So the very first, the first benefit that we talked about is achieving higher consolidation ratio and more utilization for your hardware. And the second benefit is, like, portability, because virtual machine is nothing, just a set of files. So let's say if I want to relocate a physical server, let's say from one geographic location to another. Let's say I'm relocating from Houston to, let's say, Georgia, right? These are 2 different states across US. So let's say if I want to ship a machine physically, like a physical server, it might take, you know, somewhere between 7 to 10 days, and it requires, you know, it requires a huge cost being involved, and then a lot of approvals and everything, and it takes time to actually physically ship a server from one location to another, especially when it is across countries. Maybe within state it might not take much longer, but let's say if I have to ship it across to a different country, it might take quite some time. So now in case of virtual machine, I can simply, you know, there are ways I can simply send this machine over the network. I can, or export this as an OVF, and I can simply, you know, transfer it over the network to any of the remote site. So if you see the contrast, on the physical side, it was like number of days it takes to ship a physical server, but in case of virtual machine, I can simply copy over these virtual machine files. So, and if I have a virtual environment over there, if I have a vSphere environment over there, so it will just take me minutes to import this virtual machine, and then, you know, bring it back online and start using it. Okay. So in case of physical machines, when we talked about, like, we have one-to-one mapping, and so let's say I want to do some maintenance, so I have to take some downtime for those applications. So which is not the case in the virtual counterpart. So let's say I have to perform maintenance on this physical server. Let's say some issue with the power supply, so I have to replace the power supply, or there's some issue with the RAM module, I have to replace the RAM module. So what VMware provides a feature called vMotion. So I can simply move these VMs on this ESXi host, and then once all the VMs are moved, I can simply put this ESXi host into maintenance, and I can shut down, and then I can perform whatever hardware change I have to perform. So this is pretty robust. So this is like no downtime, and I can maintain, I can perform maintenance, and let's say if I want to perform any patching of these ESXi hosts, I can do it without downtime. I'm sorry. Okay, so one more benefit we can talk about. I mean, there are a lot, but yeah, I mean, for the sake of discussion, we have some points to begin with. So once we go across into this training, we'll talk about more and more contrast features and more benefits of adopting virtualization. So let's say if I want to run a legacy operating system, let's say if I have a latest server, for example, some HP Generation 9 server, if I want to run Windows 2003 on that server, so we will not be having any that OS might not be supported because of lack of drivers and everything. But if I deploy if I deploy a hypervisor and within a VM, I can run any legacy operating system. So these are few benefits that we have just talked about. So now let's move on to the next slide and see what a typical virtual machine architecture looks like. So when I say virtual machine is a set of files, so what these files exactly contain. So if you actually browse the virtual machine folder, so following are the set of files that you would find. Okay, so let's talk about few, and once we start doing our lab, once we start deploying our virtual machines, we'll see all these files, and we also try to browse these files and see what are exactly the contents of these files. So typically when you see a virtual machine folder, the file you will for example, let's see if you have created a VM named Windows XP, so you will find the file like Windows XP.vmx, which contains the configuration of that virtual machine. So whatever configuration I assign to a virtual machine, let's say how many virtual CPUs, how much of RAM, how many virtual disks, and what sort of network, how many virtual network cards or virtual NICs. So that all those things would be stored into this VMX file. Swap file, again, it's more like, for example, if you guys are aware, like we have a paging file in Windows. So similarly, we have a vswap file. So we'll understand in what all scenarios this file would be used. So, and at the BIOS, so like you have a BIOS for your physical machine, you have a BIOS for your virtual machine, where you specify all the settings, like boot order, or if there's any specific setting that you want to configure on your virtual BIOS. And log files, the virtual machine log file, in case of any issues, you will refer to these virtual machine log files. And template file, again, template, it's being used for mass deployment. For example, let's say if I want to deploy same kind of virtual machines in my environment, so I will simply create a virtual machine. I will deploy all the patches, all the softwares and everything, and I can simply turn it into a template. So next time I don't have to go through that process of installing operating system and applications and everything. I will simply use this template file to deploy virtual machines, let's say of a similar type, right? So like in every production environment, we maintain a template for different kind of operating system. Let's say I'm using multiple operating systems in my environment, like Windows Server 2012, Windows Server 2016. So for every VM, I maintain a template file. So whenever I get a request to deploy a new virtual machine, so I simply go to the template and then deploy the virtual machine from there. The disk file is being used every virtual machine has a dedicated virtual machine virtual disk file, where the entire operating system, application, and the data is being stored. So like on the ESXi server, so whatever storage you will put, let's say it can be a local storage, or it can be a shared SAN storage, iSCSI or fiber channel. So the ESXi host formats that disk into a VMFS data store. So whatever virtual machines I create, so there would be a dedicated folder for the virtual machine, and you have all these files plus the disk file that you have. So let's say if I have assigned like single disk, so per disk I would be having these two files. One is the VMDK and one is the flat.vmdk. So the VMDK is more like a descriptor file or a meta file that contains the information about this disk data file that contains the actual contents of my virtual machines. And then you have the for let's say I have two disks, so for every disk I would be having a VMDK and the -flat.vmdk. So we'll actually see, and the size definitely differs. So this VMDK file is like pretty small file in some KBs, and this data file is the actual file which holds all the data for the virtual machine. So size is actually dependent on what kind of provisioning we are using, thin or thick. So that again we'll see once we deploy a virtual machine. We'll see how exactly the type of disk provisioning method that we use, thin or thick, how it actually controls the VM disk file size. Okay, so we have these snapshot files that we'll see like how the snapshot. So once we create VMs, so we'll see what are the uses of snapshot, and in what all cases we can use snapshot, and how to troubleshoot issues with snapshot. So we'll definitely encounter that later in the series. All right, so as we discussed before, like what are the different type of hypervisors. So we have generally two categories: type 1 hypervisors and type 2 hypervisors. So let's talk about type 2 hypervisors first. So type 2 hypervisors, like let's say VMware Workstation. So that I can put on this machine which I'm using right now. I can put a VMware Workstation. I can simply install my virtual machines. Let's say if I want to try out some application which requires a separate operating system, so I can simply install the VMware Workstation on my Windows machine, and then I can start deploying my Ubuntu, Linux, or any other machine which I need for my specific purpose. So now we come to the type 1 hypervisor. So that is again being installed on a hardware directly. So let's say if I want to deploy a ESXi, so I'll just I'll get a physical host, and then on that I can simply install the hypervisor, and then I can start hosting my virtual machines once I perform some initial configuration. Like once I set up the network, storage, and everything on that ESXi host, then I can start deploying my virtual machines. So in case of type 2 hypervisors, I mean the feature set is pretty much limited. So you can simply create virtual machines, and again they go to up to a certain extent. They are not as much scalable as a VM on a type 1 hypervisor. So by scalability, I mean, for example, the number of virtual CPU supported, or how much RAM you can provide to a virtual machine, and how many disks you can provide to a virtual machine. So the purpose, if you see the purpose of creating virtual machines, it's being supported by both, be it type 1 hypervisor or type 2 hypervisor, but the number of feature and how robust that solution is, that is actually being decided by what type of hypervisor you are using. So when I talk about type 1 hypervisor, they are being more robust. So VMware ESXi or Microsoft Hyper-V or open source KVM, these are the type 1 hypervisors. So in this training, we'll be totally discussing VMware ESXi. So besides hosting virtual machines of higher specs, VMware ESXi provides more features like memory overcommitment, and you have features like vMotion, storage vMotion, fault tolerance, and so these features, like again, they are being supported once you deploy a vCenter in an environment. So we'll see how how these various features are configured once we have a full-fledged vSphere lab. So let's move on to the next slide. So it's again more like a refresher on the benefits that we have talked about. So reduce hardware costs. So once we deploy virtualization, so we again need less number of physical servers. So definitely it's going to directly impact the hardware cost. We need less hardware, again less power comparatively. So let's say previously I had 50 servers, 50 physical servers, I have 50 applications running, so I have 50 physical servers. But now once I adopted virtualization, I can simply bring down to those VMs to like 5 or 10 servers. So again, a lot of wastage of hardware can be avoided. And again, if I have those servers, so previously I have 50 servers, so I just brought it down to 10 servers, and all the applications are now running as a virtual machine. So I have those 40 servers as spare, so I can simply use them for some other purpose, right? To have more capacity, or I can also deploy them as a ESXi host. So faster server provisioning and deployment. So like I said, in case of a physical server, you simply have to deploy a physical, let's say I have to install 10 physical servers, so I have to go and install operating systems, the patch, drivers, and everything. But in case of virtual machine, I will simply deploy it once, and I will put all the patches on all the base applications, and then I can simply create a template, and then from the template itself I can deploy virtual machines. So which is like pretty easy. It's like doing few clicks and your VMs would be ready. So disaster recovery, again, disaster recovery, it's again, it's a totally I would say a dedicated topic that we can talk about, like how we can provide like disaster recovery. So there are solutions which are being used, which can be deployed over your vSphere environment, and using that you can simply replicate your virtual machines in a timely fashion to any remote site or any co-located data center, so that you can bring up in case your primary data center goes down. So this is again a full-fledged topic. So it's just, so here I just put it here to provide you an overview. And significant energy cost savings. So when we bring down the number of physical servers, so it's definitely is going to cut down my energy cost consumption, to cut down my energy consumption. So which is like directly affects my cost savings. Increase uptime, so have feature like vMotion, storage vMotion. So like we talked about, if I have to perform any maintenance in a physical counterpart, so I have to bring down all the services and everything. But in case of virtual machine, I can simply vMotion it to any other host in that vSphere environment, and I can simply perform whatever maintenance I need to do. So it's not going to affect any of my applications whatsoever. So we'll see how these features work. So how to set up vMotion, how to do storage vMotion, and DRS, and VMware High Availability. So I will explain you all these features and how to configure them and how to tweak them, and what are the considerations which you should have in mind before you set up these features. Okay, so now without further ado, let's get started, and we can deploy our first E6i host.